Hello everyone, welcome to Java session. In today's session, we'll discuss about language fundamentals. Today's contents are primitive data types, variables, modifiers, operators. First one, primitive data types. Primitive data types are divided mainly into three categories. First one is integral types, which are nothing but it represents the signed integers like byte, int, short, long, and also unassigned character values. Floating point types. It's like decimal numbers. It represents fractional signed numbers. Boolean types. It represents logical values, which are nothing but true and false. We will see the hierarchy of primitive data types. Primitive data types mainly categorized into two sections. One is Boolean variables and numeric data types. Okay, and numeric data types again are categorized into integral and floating. Integral is again categorized into integer, character. So integer is again divided into four categories like byte, short, int, float. Character is having only character variable. Okay, character data type. And floating is again divided into two data types. One is float and double. Here boolean is boolean. Okay, next. What is the capacity of these data types? Like how much value that these data types can hold? For integers, in in integers we have this byte, short, int, long. So for byte it takes 8 bits of characters, 8 bits of data, and for short 16 bits, integer 32, long 64 bits. And the minimum value for byte data type is minus 128 and maximum value is 127. Like this we have this min and max values of these four different integer data types. And for character it holds a 16 bits of data and minimum value unicode value is 0x0 0xFFF. Okay, and for floating point we have two different data types, float, double. And float holds 32 bits of data, double holds 64 bits of data. And boolean holds I mean like we cannot measure the width of that particular boolean data type. It holds true or false. Next, variables. What does it mean by variable? A variable stores a value of a particular type. A variable has a name, type, and value associated with it. In Java, variables can only store values of primitive data types and a reference value of objects. What does it mean by reference? Reference is nothing but we already discussed. Java is an object-oriented programming language. In object-oriented programming language, everything we represent in the form of objects. So these objects have some location. So their values, so reference value of that object will store in the variables. Variables that store reference value of that object call, which is nothing but reference variables. How we declare the variables? See here we have character chr. This is a data type, and this is variable name a b c, and which ends with semicolon. In a similar way, float area, boolean, flag. So this is we call it as declaration of a variable. So data type and variable name. And initialization. How we will initialize a variable? So here if you look at int I equals to 10. So here for integer data type I we are assigning value 10. So this is nothing but initialization. Now, what are the default values for these variables? So if we don't initialize for these variables, what will system prints? Okay, here for boolean we are getting false. Okay, default value for boolean variable is false. For character slash u 000, for integer 0. Okay, for floating point 0.0f, and for reference type default value is null. We will see. I'll write a sample program here and we'll see how Java prints for these data types. Okay, the default values. Okay, here we have sample class. Okay, integer a. So how will declare data type space field name, variable name a. Okay. Now what we will do? We'll print a variable system.out.println a. Dot a. Okay. So if we print here, run as Java application. See here, default value is 0. So if we don't assign any value for integer data types, then we'll get 0. Okay. And float b char c boolean flag. So what I'm going to do now, I'm printing all these values. System.out.println s.b system.out.println s.c system.out.println s.flag. Okay, we will run here as Java application. See 0, 0.00 and character space false. Okay, default value is false. Here integer a, and also I can declare n number of variables. So if we have a similar data type, so we need not to write line by line. So we can we can declare those variables in single line. Integer a comma b comma c. So a, b, c are of integer data type. Okay. And if you want to assign any value here, I can assign value as well. A b equals to 5. If I want to print, see s dot b. So if we assign any value to a variable, then that value will be printed. Here b equals to 5. So here b 5 is printing here. Okay. So here if we have a same data type, then we can mention those variables in a single line. Okay. Next, there are three kinds of variables in Java. One is local variables, next instance variables, and static variables. We will discuss in detail. Okay. Local variables. Local variables are declared in a methods, constructors, or blocks. Okay. And local variables are created when the method or constructor or block is entered, and variable will be destroyed once it exits the method. Okay. Access modifiers cannot be used for local variables. What are the access modifiers? Access modifiers we'll discuss in more in detail, but if you look at previous public static void method, in that public is nothing but access modifier. Okay, so we will discuss more about access modifiers in next slides. Okay, and now local variables are visible only within the declared method or constructor or block. Local variables are implemented at stack level internally. There is no default value for local variables. So local variable should be declared and initial value should be assigned before we use it. So here we have 6 to 7 statements. Just I want to show how system works with these local variables. Okay, we will take an example and we will see whatever we mentioned in this slide. We will rerun those statements. Here we will write public void show. Okay, here integer a. Integer. So a equals to a plus 5. System dot out dot println a. If you look at this example, here we have declared integer a. This is method name public void show. Okay, and here we didn't specify any access specifier. Just we put int and variable name. Okay, and now I didn't initialize this particular variable. So in local, if it is a local variable and if we don't initialize, then we cannot use. Okay, so if we want to use local variables, we have to initialize. So what we'll do, I'll put here 5. Okay, so see here, now exception gone. Okay, so if I print here, what I'll do, s dot show, s dot show. Okay, I need not to print again, just I can call s dot show. Here, run as Java application. See here, 10. So what we discussed here, again we will revisit. Local variables are declared in methods. So what we did, we declared those variables in method show. And local variables are created when the method or constructor or block is entered. So this a is being created when we call the show method. Okay, and access modifiers cannot be used for local variables. We didn't specify any access modifier for a. Local variables are visible only within the declared method. So these variables only visible under show method. So we cannot use this a outside show method. So if I call a directly from main method, it will not work. Okay, and local variables are implemented at a stack level. So this is a memory structure, and there is no default value for local variables. We have already observed that we need to assign one value to the local variables. Okay, we'll go to the next slide. Instance variables. Instance variables are declared in a class but outside a method, constructor, or any block. When a space is allocated for an object in the heap, a slot for each instance variable value is created. And these instance variables holds values that must be referenced by more than one method, constructor, or block. Okay, or essential parts of an object state that must present throughout the class. And instance variables can be declared in a class level before or after use. Access modifiers can be used for instance variables. Instance variables are visible for all the methods, constructors, and blocks in the class. Okay, and normally it is recommended to make these variables as private. We will discuss why we need to make these variables as private in future sessions. And instance variables have default values. Instance variables can be accessed directly by calling the variable name inside the class. So I'll explain each and every statement which we have read now, okay, in sample program. See here, we have this sample class, right? Integer a. So this variable we call it as instance variable. Instance variable can have, so this is class level, and here integer a and even float b. So this is also a instance variable. Okay, here what I'll do, I'll use system.out.println b. So this instance variable can be accessed through all of the methods. So here b can be accessed. Run as Java application. See, then b value it got printed. So we need not to assign any value here. Default values can be initialized. Okay, here float b equals to 0.0, and we can specify access specifiers. Okay, private, protected. So these access specifiers we can specify here, and these instance variable we can directly access, like see here in this method, sample dot, sorry, object, right, is dot b. So we can print directly use these variables by object name. Okay, next one. Static variables. Static variables also known as class variables. These variables are declared with a keyword called static and within the class, but outside a method or constructor or a block. There would only one copy of class variables per class regardless of how many objects you create. Okay, so we can create n number of objects, but the variable which is always create per class level, and the static variables are rarely used other than being declared as constants. So only for constants we mostly use these static variables. Static variables are created when the program starts and destroys when the program stops. Visibility is similar to the instance variables. It is similar to instance variables, but except that it is created only once when the program starts. Okay, and default values are same as instance variables. Static variables can also be accessed with the class name dot variable name. Okay, I'll show you how to call the static variables from the static methods. Okay, private static char or in C. Okay, so here we need not to call with object name dot variable. So directly I can call sample dot C. So by class name dot C we can call like this. Dot dot println sample dot S. So here I'm printing sample dot C. See here we are getting 0. Okay, we'll go to the next slide. Now modifiers. There are two types of modifiers in Java. One is access modifiers and another one is non-access modifiers. So access modifiers which control the variables or methods or classes. Okay, so here there are four different types of access modifiers. Default, it is visible to package. Package is nothing but in Windows how we have folder structure, in the same way all the classes are grouped into one package. So this default access modifier is visible to only package and no modifiers required. So here if default package means we need not to specify default keyword for variables. And next one is private. This is visible to only class, means if you define private int a, okay, private int a in a class sample, so this a variable is only visible to class sample. And we have public is visible to the world, so you can access from outside the class as well. And protected, it is visible to the package and subclasses. If you subclass from any class, then you can access those protected variables. Next one, non-access modifiers. Java provides a number of non-access modifiers to achieve many other functionalities like declaring the constants. So for declaring the constants we'll use static and final keywords. So these are the access modifiers, non-access modifiers. So we have four different types of non-access modifiers. Like static, the static modifier is used for creating class methods and variables. Final modifier is used to finalize the implementation of classes methods, which is nothing but if you don't want to change anything or if you don't want to modify our particular method, then you can make those methods or variables as final. Next, abstract modifier is used for creating abstract classes and methods. And synchronized access modifier, this is used in threads concept. These threads we'll discuss in future sessions. Next one, operators. So Java provides a rich set of operators to manipulate variables. There are multiple operators we have in Java. One is arithmetic operators, okay, and relational operators, bitwise operators, logical operators, assignment operators, miscellaneous operators. We'll go each and every operator in next slide. Arithmetic operators. These arithmetic operators are used in mathematical expressions. Like if you want to add two numbers, subtract two numbers, or multiply two numbers. So these operators, whatever we are using, those for calculations, those operators are known as arithmetic operators. If you look at this table here, plus is used to add two numbers. minus is used to subtract, star multiplication, division, modular, plus plus minus minus. What is this plus plus minus minus? So these plus plus minus minus we call it as a unary operators. So if you have only one operand, then we call it as a unary operators. Whereas if you are performing operation between two operands, then those operators are operators we call it as a binary operators. If a holds 10 and b holds 20, then a plus b here it gives 30, 10, 200, 20, 21, 19. Okay, so what we'll do, just we will run using these operators in a sample program. Okay, here we have integer variable a equals to 10, b equals to 20, and this is arithmetic operators method. Okay, here a plus b, a minus b, a into b, b by a, b mod a plus plus, a minus minus. Okay, I'll run this one as Java application. See here, addition of a and b 30, subtraction of a and b minus 10, multiplication 200, division 2, modular 0, addition 10, subtraction 11, and 20. Here we are printing b and 20. Okay, this is how these operators are being used to calculate two operands or more than two operands. Next operators is relational operators. These relational operators are used to compare two operands. See here, if a holds 10 and b holds 20, here these are the relational operators, equals to equal, double equal. Okay, checks if these two values, two operands are equal or not. If yes, then it returns true. If they are not equal, it returns true. If they are equal and if it is greater than a is greater than b, then it returns true. If it is less than, it is false. Okay, less than or equals to, greater than or equals to. So like this we can compare two operands using these relational operators. Next, bitwise operators. So bitwise operators can be applied to integers. Okay, and integral types like byte, int, short, long numbers. Okay, and this also works on bits and perform bit by bit operations. Like if you consider a is holds 60 and b holds 13, so how will represent this 60 and 13 in bit format? Let me show you. So what we said, like a holds 60, so how will represent 60 in the bit format? Okay, see here, this 0 represents 1, and this 0 represents 2, next third digit represents 4, fourth digit represents 8, so exponential of 2, and this one represents 16, 32, 64, 128. Okay, so this is 1 byte, 1 byte 8 bits. Okay, so this 8 bits for 60 how will represent? So here 32 plus 16 48 plus 8 56 plus 460, so 0011 and 1100. So this is 1 byte of one representation of 160 number. In the similar way for 13 0000 1111 0. So now how bitwise operators work with these numbers? Here ampersand. So this binary AND operator, it copies bit of the result if it exists in both the operands. For example, here in A we have 1 and in B we have 1. So if it exists, this 1 and 1 exists in both these operands, then will you print 1. Otherwise, if A is 1 and B is 0, then will represent as 0. Okay, so let me explain in program here. So if I want to print a and b, okay, a and b here, so we'll come from starting on 0 and 0. So 0 0 and 0 0, 1 and 0 0, 1 and 0 0. Okay, first four digits over. Next 1 and 1 1, and 1 and 1, 1, 0 and 1, 0, 0. So now what is the value of this 0, 0, 0, 1, 1, 0, 0, which is nothing but, see here, 1, 2, 4, 8. So the value of this number is 12. So if we ampersand, if we do bitwise AND operation between 60 and 13, then we'll get the result of 12. Okay. So A and B will give 12. And binary OR operator, A binary OR single pipe symbol will give 61. A XOR, binary XOR operator, it gives 49. Binary ones complement. So what it will, binary or means 1 or 0, then it will always return 1. Okay. Binary XOR operator, if it is set in one operand but not both. Okay. Here if it is set in one operand and but not both, then that is a binary XOR operator. And binary ones complement means if it is 1, then its complement 0. If it is 0, then its complement 1. And binary left shift operator, what it does, this left operand's value is moved by the number of bits specified by the right operand. So whatever a right operand we have, based on that right operand, it shifts to the left side. And in the same way, a right operator, a right shift operator, so it moves. If it is a less than 2, then it will move 2 bits. Okay, it moves towards left 2 bits. Okay, in the same way, a greater than 2, it will shift towards right. Okay, 2 times. And shift right zero fill operator, this the left operand's value is moved right by the number of bits specified by right operand. So you can practice these operators using sample program. Okay, next one, logical operators. Logical operators returns the boolean value. Here operands, boolean values. So in previous operators, those operators are being used in operands. I mean, like those are integers, okay, float numbers. But coming to logical operators, they always deal with the boolean operands. Here we have logical and ampersand 2 ampersands a and b. Okay, if a true and b true, then it will always return true. If a true, b false, then false. Okay, a false, b true, false. Okay, and false false false. And in the same way, logical or operator and logical not operator, a or b is true. Next one is conditional operator. What does it mean by conditional operator? Conditional operator is also known as ternary operator. This operator consists of 3 operands. So far what we discussed, one operator is, I mean, like unary operator, binary operator. Unary operator is always having one operand. Binary operator, it consists 2 operands, okay, a and b. Coming to the conditional operator, this ternary operator, we have 3 operands, a, b, c. Okay, the goal of this operator is to decide which value should be assigned to the variable. See here, variable x equals to some expression, question mark, value, colon, value. So if this expression satisfies, if it is true, then after the question mark, whatever the value we have, it will be assigned to the variable. If it is false, after colon, whatever the value we have, that will be assigned. For example, here a holds 10. Okay, now integer b equals to a double equals to 10 question mark 20 colon 30. See here, is, so double equals to is nothing but, we are whether a equals to 10 or not. Okay, yes, a equals to 10. So if a double equals to 10, yes, true. So if it is true, then after the question mark, what we have, 20. So 20 will be assigned to b. So this is nothing but, so if suppose a is having 5, okay, and integer b equals to a double equals to 5 question mark 20 30, then b will be printed as 30. I'll write it down in a sample program and see how the results are coming. Here we have method called ternary operators. Okay, a equals to 10, and here ternary operator. Okay, b equals to, this is one expression, a double equals to 10, so it compares. Okay, uh, and what it will return the value, a equals to 10. If it is true, then it will return true, or it will return false. Okay. So here a double equals to 10. Okay, so it is true. So if it is true, then after question mark, whatever the value we have, that will be assigned to b variable. See here, 20. Okay, suppose I'll change here a equals to 5. Okay, now 30 will be assigned to b. Run as Java application. Okay, now we have 30 to assign to b. So now we understood different operators, right? And operators precedence. So these operators precedence determines the grouping of terms in expression. It means like how the expression should evaluate. Okay, certain operators have high precedence than other. For example, if we have x equals to 7 plus 3 into 2, so here multiplication is always higher precedence. Okay, so if you look at like this example, 7 plus 3 into 2, then what value can be assigned to x? It is, first we need to multiply 3 into 2. Okay, 3 and 2, 3 into 2 is 6, 6 plus 7, 13. 13 will be assigned to 7, not 20. We should not add 7 plus 3, 10, 10 into 2, 20. So it's not like left to right order. So it depends on the operator's precedence. So here multiplication is always higher precedence. So always value will, what value will get here, multiplication will be first having higher precedence. Okay, so this table determines the operator's precedence. So first of all, postfix, okay, and arrows, braces, unary operators, multiplicative operators. So if any operators are there in any expression, so these precedence will follow. Okay, if you have any queries on today's session, please mail us at info@bicourses.com. We are happy to answer your queries and questions. Thank you so much.